Like, what are the things that we really should be eating every day?
It's a tough one. Who's going to start? I guess I can.
Help me, Rhonda.
That's a
help me.
loaded question.
Alrighty, hello everyone, and welcome to another episode of #FoodTruth, where we will be talking all things food with incredible experts from how food impacts our health, our environment, and our behaviors. I'm your co-host, Sharon Cryan, attorney turned food nerd.
And I'm your co-host, Dr. Kevin Lyon, family medicine physician and co-founder of the Anti-AGEs Foundation. Today we'll be talking about Healthspan, longevity, and disease preventative measures, how to be a superhuman.
And I'm really excited because today's guest, we have the dynamic duo of Dr. Rhonda Patrick and Dr. Jed Fahey here. Dr. Fahey is a nutritional biochemist with broad training and extensive background in plant physiology, human nutrition, phytochemistry, and nutritional biochemistry. He spent 27 years as a faculty member at the Johns Hopkins School of Medicine. Until retiring last year, he ran the Coleman Chemo Protection Center, which he helped create, and has for many years developed plant agents such as broccoli sprouts for the purpose of enhancing health span.
Dr. Rhonda Patrick is a biochemist known for her extensive research on aging, cancer, and nutrition. She attended University of Tennessee, where she got her PhD in biomedical science. She did her graduate research at St. Jude Children's Research Hospital and trained as a postdoctoral fellow at Children's Hospital Oakland Research Institute. She has done research at the Salk Institute for Biological Sciences, has several journal publications, and is the founder of the website and YouTube channel Found My Fitness.
Awesome. It is an honor to have you both here today. This is quite an opportunity to have you both being interviewed. Usually it's on to rather Rhonda interviewing Jed or vice versa. So I'm excited to have you both here. Thank you.
Thank you for the invite. I'm always excited to have a conversation with Jed, and it's nice to meet some new people as well. So I look forward to our chat.
I'll save time and echo what you said, Rhonda. Ditto. Back at you.
Awesome. So what we're going to be talking about today, health span, longevity, disease preventative measures, just how to be the best superhuman that you can be. And what makes you guys both really experts on this topic is your research and your unique point of view of research. You know, you are both biochemists, which, puts you in a very, unique point of view from the research, or you're really deep in it. And so if we can just kind of get an idea of why biochemistry, why do you do what you do? Obviously, you guys chose a very difficult research path. So can you just tell us like the main reason?
Well, it's funny that we both have a biochemistry background. I'll be brief with mine. I sort of, in college, I was a surfer and wanted to do something marine biology related, or I wanted to be like David Attenborough, where I was like going out in the field and like studying animals. And so in order to do that, you had to have a science background. And I started, I was like, okay, I'll do that science major thing. And being the competitive sort of person that I am, there was multiple choices for the science background. And I decided I was going to do the hardest one, and then from there, it was like I was in a lab, and then I was interning in labs, and one thing led to another, and that's kind of how it started. So it wasn't like a real active decision on my end.
That's awesome. I didn't realize that you wanted to get into marine biology. Is that something that you kind of do some work in still, or did you completely separate, go a separate direction?
No, I absolutely went a separate direction. It's like you want to do this field work, and then you like have to take all these science classes and you get stuck in the lab, and then like it's like a different world, and I completely forgot about it. And I think for myself, what happened to me is the first lab that I was really excited about the research was at the Salk Institute, and I was in an aging lab where we were using these nematode worms. They're called C. elegans, and they're great for studying lifespan because they have about a 2-week lifespan, and there's a lot of homology in genes that they share with humans. So homology just means like the sequence of the DNA sequence is similar in many respects between the worms and the humans. And so, for example, they have genes that are involved in, the insulin receptor and all that sort of stuff that we have in humans. And so they're a great genetic model to study aging because they have a short lifespan and you can genetically manipulate them. You can turn genes on or off, or you can make them active all the time, or you can slow them down, and you can study the effects on lifespan and sort of extrapolate, well, what's going to happen in humans? We have these genes. And so for me, that was the first time that I, decided I wanted to go into, I was interested in aging and age-related diseases like cancer, because I was seeing that I could manipulate, one gene, extend the lifespan of this worm by 100%, and then realizing, oh, the insulin growth factor signaling pathway, we have that in humans. Amazing, and you see it with your own eyes where the worm is youthful throughout its lifespan, and instead of, the worm sort of after a few days that becomes sedentary, can't move very much, and it barely just moves its little nose around to feed. And so that was for me the first time that I decided, oh, I forgot about all the other marine biology and field work and all that stuff. And I was like, this is cool, So that was kind of my experience.
That's awesome. And Jed?
Yeah, Rhonda, I didn't realize you were a marine biology nerd before you are what you are now, because I was too. And I'm older than you, so my story could be longer, but I want to try to keep it short. I grew up on Long Island, in the same town as Long Island oyster farms, and I always thought I was going to grow oysters or mussels in aquaculture when I was in junior high school or high school. If I did anything, and I aspired to be Jacques Cousteau, who was a big shot back when I was a kid, and but I also was if I do say so myself, quite an accomplished young classical cellist. So I was really being groomed to go to conservatory and was ready to apply to Juilliard and some of the big conservatories. And I dropped an air conditioner on this finger on my left hand, which is very key to playing like in an audition. So this was during audition season. So it was like, okay, no music, let's apply to college. So I applied to college, majored in marine biology or earth and planetary sciences, and then said, okay, what do I do with this? Nothing at that time. And so I went and got a master's degree in algal physiology and did a thesis on spirulina or spirulina, which many of you will be familiar with. And that led to wanting to save the world and feed the world, I should say. And then I realized, as I kept on hitting sort of brick walls, because you're not going to feed the world with spirulina, unfortunately, I realized everything got back to biochemistry. And so to answer your question a little bit more directly, that sort of nurtured my realization that you had to do some biochemistry to be able to do any of the things that I thought I wanted to do. And then the story, goes on and on and on. And it wasn't actually until I came to Johns Hopkins, that I got my doctorate in nutritional biochemistry. And that was many, many years later, when I realized that in addition to learning biochemistry, you had to have a doctorate if you wanted to do anything in the field, my chosen field of feeding the world. So let's stop it there, because there are more interesting things to talk about.
Can I add a follow-up question? Just the spirulina aspect. So is that so that's blue-green algae, right? Is that the one that has high levels of the microcystin toxin?
Yeah, but no, I don't think it does. But go on. So
I was going to ask you. There's so many.
It's a corkscrew-shaped blue-green bacterium or alga, depending on what camp you come from, and very high in fairly digestible protein. But go ahead.
Well, that was my question was there's you can find a lot of green powders and which have, some of them have a great micronutrient profile and but I've always been concerned when I see spirulina in there because of the contaminants. Do you think that's a valid concern?
Probably not. I mean, it's been many, many, many years since I studied it, but what I was looking at was the extracellular slime or polysaccharide capsule that the alga, that spirulina produces. Because, and this is key to the answer of your question, spirulina grows in highly alkaline or basic lakes, freshwaterish, but I mean, they've got huge amounts of sodium bicarbonate and they're very alkaline. So alkaline that almost everything else is excluded from growing there. So my advisor at the time and I, in fact, we flew his 4-seater Cessna down into Mexico, and we're looking at spirulina growing in Lake Texcoco outside of Mexico City. There are very few. Lake Titicaca in Peru, I believe it is another. We didn't fly there, but that's another place where it grows. And in Tanganyika and some salt lakes. So it's a very exclusive place or environment that it grows in. And however, now that it's being cultured fairly widely, I suppose you could get contamination. Interestingly, while I was working on it, I had spirulina slimed everywhere in the lab, and I developed an allergy to it. My elbows would break out in this rash. We couldn't figure out what was going on. And it was, because I was leaning in the hood, messing with it, and probably not very careful or professional back then. I was getting my algology wings. So, but yeah, at the time it was, this is back in the mid 70s, late 70s. It was almost unknown except to a few wacko nutritionists. And it got legs, not thanks to anything we did, but it just did. Yeah.
I was gonna say, didn't it initially get legs with a lot of it was used with horses? I think that's where a lot of the research came out of, where recovery and repair for horse racing, if I'm not mistaken. I think that's where a lot of, I guess, the animal research was around. And I think it's out in Oregon. There's a lake, a really famous lake that produces that culture, I guess, grows it there, or it's naturally grown there. But what percentage would you say you think is actually cultured versus what's actually harvested from bodies of water?
I sign out on any of those questions. Yeah, I suspect it's mostly cultured now because
mostly cultured. Okay.
But I don't know. Yeah.
So would that, Rhonda, would that then cut your concern for contamination if it's mainly cultured?
I don't know. I think you need to find an expert and do a podcast, Sharon.
Sounds brilliant. Yeah, no, I mean, it's a very, I definitely actually had some in my smoothie bowl this morning, but mainly broccoli sprouts, but I did put some spirulina in there. But it is just, you just look at it and it's just so insanely vibrant. It's one of the most vibrant things that you can put in your food. It's just full of micronutrients, but like most things, we probably don't know exactly where it comes from and what went behind it. So next podcast, that's what we'll be talking about.
I will volunteer to work with Rhonda to help identify a suitable podcastee or subject or target for that. Yeah.
Awesome. To be continued, I guess.
So yeah.
All right, let's move forward a little bit. Jed, I know this is kind of more in your wheelhouse here, but let's talk about the idea of a health span. What is it? Why is it important?
So health span is a term that when I started in public health in the 90s, really, I'd never heard of, and it was not very popular among many of my colleagues. But we meaning me and others that I hang with, run with, define health span as the enjoyment of good health or aging with minimal handicap and near full function for the duration of a vigorous and productive natural life. And what that means in pictures is, I happen to have a picture which I'll send along for you to show your listeners. But if you plot time, years of life, or lifespan, not health span, on say the x-axis versus quality of life on the y-axis, what do you get? Well, as long as you survive childbirth, as you survive being born and survive the first 5 years, you have a relatively decent quality of life. And then over time, it goes downhill, especially in the West, especially in this culture. and you become fodder for gerontologists, and you develop concurrent chronic conditions or chronic diseases. That's not, one must think that's not the way the human biology always was, although, you know, we can talk about that ad nauseum. But what we view as Healthspan is essentially the area under that curve, or integrating the area under that curve. So the question becomes, what if you could raise that curve and you didn't start losing quality of life over your aging, but you maintained a quality of life, and then one day you just don't wake up at whatever your predestined, genetically predestined, and environmentally predestined, we have to say, end of life might be. And you can talk about telomeres and talk about bad genetics all you want, but essentially we want people to live healthy and then just die. I mean, don't wake up one day. That would be the ideal. That's the way I want to go. And so
personally, I would love that. If all my patients came in and they were healthy as a horse, and then one day they just didn't show up anymore, they died peacefully. I mean, that would be the way to go. It's not the best topic, talking about death, but unfortunately, in my profession, we see so many people come in, and basically from their late 50s, early 60s and on, they're on anywhere from 10 to 15 to upwards of 20 medications. They're not doing well. Their quality of life is extremely poor. And it's sad to a certain extent to have to see them live that way for so long. So the idea of actually increasing your quality of life and having that plateau instead of the downward dip towards the end of your life would be fascinating.
Well, Kevin, the one of the things that, I mean, the reason I was happy to define Healthspan and to sort of tell you about it in that way is because obviously I have a couple of other things I wanted to say, and they echo what sort of where you're going, I think. And that is that how do you square off that quality of life curve? I am a very big proponent, as I think everybody on this podcast is, of phytochemicals or phytonutrients as one of the ways to do that. Most everybody probably in your listening audience has heard about the blue zones and has heard about the fact that there are populations that live damn healthy lives until they don't. And we can talk about the reasons, but a lot of it has to do with the plant-based diets or plant-forward diets that they eat. So when you look at the US, and Tom Kensler and I have published on this a number of times, but as of 6 or 8 years ago, we said that the 2/3, I think it was 3/4 of our healthcare budget is spent on chronic disease treatment. Something like 20% of our gross domestic product, and something like 20% of the federal budget. Hardly any of it goes to prevention. I just checked this morning because I knew you were going to ask about this, and found the following. It's a couple of years old, but the following statistic, that in the US, if you look at multiple chronic conditions, look at the top 10, a quarter of Americans have multiple chronic conditions. Half of adults between 45 and 65 years old have multiple chronic conditions, and 81% of adults older than 65. And that just, it's mind-boggling. And we know, I mean, we sound smug saying it, but I think we know one of the ways you can avoid some of those conditions, right? Take it away, someone else.
All right, can I add in? I think
Please.
The what you were to speak directly to what you were just saying, Jed. You mentioned earlier there's obviously a genetic component to the way we age, and there's a lifestyle component as well. Mm-hmm. And I've seen numbers anywhere between 40 to 60% is genetics, and the other anywhere, again, you've got 50 to 60% is lifestyle. It's a scale, but in terms of the difference between maximum lifespan, average lifespan, and health span, they're all interesting. And maximum lifespan refers to the oldest age you can live to be. And we know, at least for humans, they can live to be around 121, right? That's I think the oldest recorded, lifespan for a human. We know that, in the United States, the median or the average lifespan differs from country to country. And that could be a combination of different genetic makeups, different ethnicities. There's different single nucleotide polymorphisms that are common within a certain ethnicity. And there's also different lifestyles and cultures and, many different factors within different, regions of the world as well. But we know in the United States, our average lifespan for a female is around 82 to 83. And for a male, I think it's something like 4 to 5 years shorter than that in the United States. In Japan, for example, the average lifespan is about 5 years. The life expectancy is about 5 years longer than in the United States. And there was a really interesting paper from Bill Harris, Dr. Bill Harris, who's one of the amazing. He is just a rock star in the omega-3 fatty acid field. He's been studying it for decades and decades. I mean, he was like, right after the Dyersburg, one of the famous papers that came out looking at the Inuit population, the Eskimo Inuits, and how they have like very little heart disease. Well, he did this study looking at what's called the omega-3 index, which is a biomarker of both the marine omega-3 fatty acids, EPA and DHA, in red blood cells. And the reason he does it in red blood cells is because it's a long-term omega-3 biomarker versus, I would say, the majority of any type of omega-3 test that you were going to do or ask your doctor, your healthcare, professional to run for you, it would be plasma phospholipids. And that's a very short, it very much reflects your what I ate last night or what I ate 2 days ago kind of thing. Whereas red blood cells, you're talking about the last 28 days. And so it's a much more accurate biomarker of someone's omega-3 status. So the omega-3 index, which Dr. Harris co-founded along with another scientist who I can't remember his name, unfortunately, but he found that in the United States, the people that had an omega-3 index of about 4% had the lowest average lifespan versus people in the United States that haven't had their omega-3 index about 8%. They had a 5-year increase in life expectancy compared to the group with the low omega-3 index. And what's interesting is that in Japan, so in the United States, the average omega-3 index is about 4%, 5%. So people don't eat enough. They're not getting enough of the omega-3 fatty acids, and particularly the ones from fish. In Japan, where they eat a lot of seafood, they have an omega-3 index it's the average of around 10%. And again, their life expectancy is 5 years higher than, in the United States. So there are obviously factors in our lifestyle that affect the way we age, that affect disease risk, and certainly health span, which, as Dr. Fahey referred to, really is talking about extending the youthful part of your life, keeping you disease free when you're older, not necessarily making you live, longer, just improving the quality of your life because you're not going to get Parkinson's disease or Alzheimer's disease or have type 2 diabetes earlier in your life, which really decreases the quality of your life. I think the quality of your life there's no doubt that lifestyle plays a huge role in that. Now, whether or not you're going to make yourself live, to be, 100 years old based on your lifestyle factors, I'm not sure. I think there's also a large genetic component as well in that.
But
That's interesting. Oh, sorry, Jed.
No, go ahead.
I was just going to say, it's, of everything that we see related to Healthspan, I feel like, diet is a huge component, but all these other lifestyle factors, these compounding factors that are just nearly impossible to measure. You mentioned Japan. I did a study abroad when I was in college in Japan, and there was just such a different lifestyle. The food was different, the quantity of food, when they ate, all these different factors, but it's so hard to measure so many of these factors that, reduce stress, different types of stress. That must be so frustrating as researchers to look at something like Healthspan and say, okay, what can we, dissolve down from all this research, and then there's just this huge pocket of things that we can almost never measure, right? I mean, do you guys feel like the Healthspan, like it's becoming something that is easier as more data comes out, all this lifestyle data, or is it still, something that is just mainly diet and stress related, those two factors?
Do you want me to go, or Jed, or do you want to
go? We both have things to say about it, I'm sure. Go ahead. Go ahead.
I mean, I think that identifying biomarkers that can, obviously empirically be measured are key for looking at Healthspan. And I think there's a variety of biomarkers that are now coming out that are being vetted as that. And I honestly think the omega-3 index is one. I do. I think it's one of the important ones. And it certainly reflects lifestyle, diet. But there's others. I mean, there's inflammatory biomarkers, and you can measure stress-related ones as well. And certainly, things that are stress-related also affect inflammation. And so there's a lot of crosstalk there as well. Mm-hmm. But there was a study that came out of Japan. This was in 2015, where there was a variety of different age groups. There was elderly people that were in their 80s. There were the centenarians that were 100. There were the semi-super centenarians that were about 105. And then there were super centenarians that are 110. And there was a panel of biomarkers measured. We're talking like 12 to 18. And, we're everything from HbA1c, which is a long-term marker of blood glucose levels. You're measuring, the standard lipid panels, looking at LDL and just all the normal stuff, liver enzymes, things like that you would do in just your routine physical. But they were also looking at a variety of inflammatory biomarkers. They were looking at telomere length. They were looking at immunosenescence, which refers to your immune cells not being able to be functional, although they're still there. They're just not really functional. So there's a variety of things that were looked at. And the only thing that was actually consistent for a person to advance to the next stage, centenarian, semi-super centenarian, and super centenarian, was the suppression of inflammation. And so lower inflammatory biomarkers. And they did a whole panel, not just high sensitivity C-reactive protein, which is like, I would say, a common one that's used in clinical practice, but it's not the only one. I think there's a panel of them if you're trying to be comprehensive that were looked at. So I thought that was very interesting because, you often think of like, well, telomere length, and that wasn't actually important to advance to each stage. But yeah, let's hear what Jed has to say.
Yeah, well, I mean, you've said the word multiple times in your shall I call it a rant, but no, in your discourse just now, that I really want to stress, and that's biomarkers, and I think especially in this last half decade or so of sort of that was rife with a lot of anti-science. I mean, we can talk about anecdotes as much as we want, and it's anecdotes of I felt better, I had more energy, blah blah blah, are really easy to spew out there, and but as physicians and as medical practice professionals, wouldn't you rather, and I ask this question generally, not to anyone specifically, but wouldn't you rather have some scale that 1 to 100 or whatever that scale may be that relates to something that you can actually measure? Because you can't add up all the anecdotes of and really make a lot of sense of them. All you can do is use those anecdotes of I felt better to move the research forward and to do some critical research. So the critical research, I think, is so much of it now is that we need reliable biomarkers of health span. And I agree very much with what you say about lifespan. I have doubts that we'll ever move the needle on lifespan very much. And I'm not interested in having a twice as long a life if it's a life full of ill health and chronic diseases. So, but if instead of just measuring CRP and a few other things, or a long list of things in your blood chemistries, if you can get some biomarkers that are really indicative of what's coming to you down the road, I think the medical profession will embrace that wholeheartedly. I think it will enable them to be much better at being prescriptive about better health. And I think it will eventually, it's going to take a while, but I think it will allow non-scientists, i.e. most patients, I guess you could say, to believe or to take their physician's advice more than perhaps they are now, because we all know how many people get recommendations on diet and exercise from their physicians and go back home and don't do any of it. So why is that happening? Kevin, Dr. Lyon, sorry. I mean, you may have an idea on that, but I'm sure it's frustrating as heck for you all.
Yeah, this is a great topic that you bring up, and it's something that I kind of, Sharon hears me rant about it a lot, but it's absolutely frustrating. I think one of the biggest issues is education and awareness among physicians to know how to educate their patients in the right way, and then this kind of default into just recommending, literally, and I quote you, diet and lifestyle modifications, and that's what they'll put in your physical paperwork, and that's what they'll tell you in the room, and that'll literally be the extent of that conversation for the most part. Maybe they'll tell you, oh, you should exercise, 4 or 5 days a week, 30 minutes of cardiovascular exercise each time, or you should, switch over and have, more lean meats or lower calorie monitoring. But they rarely get into any sort of real detail about what specifically you should be eating, what specifically you should be doing to change your lifestyle to have, as you call it, a longer health span. And it's very frustrating. I would love it if there was a single biomarker test that I could order at a physical, something I can monitor and show my patients some physical proof, like, hey, here's how you're doing. Things aren't looking too great. We need to switch some things up, and we can keep monitoring this and see how it's going to go. And unfortunately, a lot of the markers that they research, for inflammation, like ESR or CRP numbers, those aren't very specific. They can often be elevated for a number of reasons. So that's commonly why we would never order those in a routine physical. So until we really get more research or different biomarkers that can give us a more accurate number to go by, it's not really something that's probably going to be impacting patient care anytime soon.
But wouldn't you? I mean, just to sort of challenge what a little bit what you said, isn't it that what we need is a better, more of a consensus on biomarkers, because they're all over the place, the papers are all over the place, and that consensus could develop. And if it develops, then wouldn't you? Or would you, not wouldn't you, that's a setup, but would you agree that it would ultimately help you do what you're doing? If there was better consensus on biomarkers, which will only come from more and better research on them, certainly.
Yes, 1,000% agree with you. That would excite me very much if we could have a consensus on those things. And the other thing is, even right now, would I like to order some of those, those inflammatory markers on some patients just to get an idea of where they're at? Yes, but that, unfortunately, because there is no consensus, the insurance companies aren't going to pay for it. Right. And that's oftentimes, we talk about a lot, kind of insurance companies involving themselves in patient care, but the truth of it is that they really do control a lot of what we can and can't order. And honestly, if the insurance company is not going to pay for it, the patients definitely can't usually afford it, and typically, and it's not something that we can test for. So we're kind of between a rock and a hard place right now. So yes, to answer your question, we definitely need a better consensus so that we can hopefully in the future agree upon it and get insurances kind of back us up on that.
Yeah, I just, I'm the non-scientist on the team. I think most patients, most average people don't realize the wall between research and their physicians. I feel like there's a lot of misunderstanding there, that you think that when you go to the physician that they're aware of, all of this research that, people like you, Rhonda, are talking about on YouTube. They may come across a video like about these markers, or being able to really monitor their health in such a sophisticated way, but it hasn't crossed the barrier from the research realm into the actual patient care realm, which is, as an attorney, I always know that it usually takes decades to get things, from research into policy or into the, mainstream awareness and education. But it makes me so sad because there's so much research on these just little things that can be done that can dramatically change someone's life. I hear you, want to talk about sleep patterns and all these different things that, and when to eat and how to eat. It's almost like because there's no consensus, those little changes that we know would make the biggest improvement on chronic disease, people suffering with chronic disease, it's just like this firewall is up. And so I'm curious, as researchers, do you communicate often with medical providers, or is it you guys are kind of each in your separate bubbles?
Well, for me, through Found My Fitness with YouTube videos and podcasts and articles and stuff, we have a huge physician following. We have a lot of physicians that are very interested in learning more about, the low-hanging fruit in terms of what can be done with diet and lifestyle to improve biomarkers, to improve, what we think might improve health span. And I think that there's a lot of research that suggests that there are things that can be done and that can be measured. And but we also have people that are, following it, and they're going and using companies like WellnessFX, which I don't have any affiliation with, but like you can go and order a variety of blood plant panels, and they have really good ones. They have, panels of inflammatory biomarkers that you can measure. That's not just high sensitivity C-reactive protein, so they have, you have people that are also really interested in preventative healthcare and in optimizing their diet and their lifestyle based on science. And so they're trying to learn themselves, and they also communicate with their physicians and work together. And so I think there's a variety of different ways that people are trying to improve their lives and the lives of their family members and friends. So
awesome. Yeah. And those are really the early adopters, the people that are very hungry for this information. But I think one of the things that I wanted to go back on, I want to make sure we touch on it because I feel like we could talk for a long time on this, but I want to talk about phytochemicals. And then Jed, you have some to add.
Let me just, before you go to the next question, I just want to say, I agree with everything that you've said, but and I love the way Rhonda communicates out to people, but critical is that there are a ton of underserved people in this world who either don't have time, don't have background, or don't care to sort of digest all this information themselves and request various tests. And so I think it's extraordinarily incumbent that all these messages do get along to Rhonda's physician audience and to others, because ultimately, a lot of people, if they're lucky, only go to their physicians for that sort of advice. So, yeah, I mean, and we're talking about very privileged compared to the rest of the world, very rich Americans mostly. So, anyway, sorry to interrupt, Sharon, but
no, thank you. And that's a huge point. But but I think why these tips that we're about to talk about, these are things that people can implement, and yes, they don't have to necessarily go do all these tests or become their own little biohackers in sense. But can we talk about phytochemicals, because we do know that everybody has access to plants which are very rich in phytochemicals. So let's talk about phytochemicals, and I do want to touch upon sulforaphane as well. So if you guys can attack that'd be awesome.
Okay. Yeah, who wants to start with the phytochemical? How about Mr. Phytochemical, Dr. Jed Fahey?
Sure. And as one thing I'd like to throw out there is, in another podcast someone does, it would be really interesting to talk to vegetarians and vegans and talk about how that squares with the theory that human life may have evolved near the seashore for access to marine omega-3s and marine fatty acids. I'd love to be a fly on the wall listening to that conversation. Anyway, so back to phytochemicals. We define them, most people define them as the non-nutritive plant chemicals that confer health benefits to humans. The estimates are, and so they are typically small, they're small molecules. They're not proteins, carbohydrates, fats, or fibers. They're not the stuff, the big stuff in plants. And as a result, they're also much by far the most easily things that are lost, corrupted, or destroyed in processing, which is a reason to eat raw or minimally processed plant foods, as well as everything else, frankly. The phytochemicals include the colors, the scents, 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 and the various compounds that have antibiotic activity in plants and defensive activities. They confer advantages to the plants by and large, and all sorts of advantages that we could spend hours talking about. And humans, in many cases, co-opt those advantages for their own health, their own benefit. So, I mean, I guess in short form, that's what phytochemicals are. The estimates as to how many there are range from a conservative estimate, very conservative, I think of 50,000 that Tom Kensler and I put in a recent paper of ours, to 5 to 10 million. And they've been described by others as the dark matter of nutrition, which I think is I love that term, the dark matter of nutrition, because they're mostly invisible to epidemiologic studies, right? You get a big epidemiologic study, what are they looking at? Not sulforaphane or, quercetin. They're looking at the carbohydrates and the fats and the proteins. So, and I think the sad thing, in my opinion, is that as we looked at some of the big consensus documents on nutrition that have been put out recently, including the guidelines, dietary guidelines for Americans 2020 to 2025. That's a big, weighty document. Do a word scan through there. Phytochemicals, phytonutrients, plant defensive compound, none of those words are used at all. I think they say something like plant rich or plant forward in a couple of places. And we've looked through a number of other major documents put out by nutritional organizations, and they ignore phytochemicals by and large because there are a zillion of them, and there isn't consensus on very many specific phytochemicals. Someone else's turn. Dr. Patrick?
Well, sure. I mean, you really covered a lot there, Jed. I really like thinking about, in addition to that wonderful, very comprehensive sort of definition, I like thinking about the evolution of it as well. And I know a mutual friend of ours, Dr. Mark Mattson, who is a great neuroscientist, used to be at the NIH, and now he's an adjunct professor where Jed formerly was at Johns Hopkins. And he to some degree, I'm referring to him because I've read a lot of his papers, and I recently interviewed him on my podcast a couple of months ago, and he talks about a lot of these phytochemicals in an interesting way. Some certainly, like not all of them, but like some of them, as these plant insecticides. So these plants have evolved a way to produce chemicals that can keep insects away and from eating them and destroying them. And so a lot of these phytochemicals or plant insecticides, in some cases, will affect the nervous system of insects. They'll kind of make them a little wonky, so they can't figure out to go bite the leaf, And so humans have evolved ways to basically ward off the potential toxicity of any of these insecticides by activating a variety of genetic pathways, to get rid of the potentially toxic plant insecticide, and to activate a variety of anti-inflammatory pathways and antioxidant pathways, and the pathways that are activated to detoxify in some cases. Some of these plant phytochemicals have a variety of benefits that come along with that. So as the expert, Dr. Jed Fahey, knows, one of those pathways would be the Nrf2 pathway. And so I really like thinking about those phytochemicals in that way, because we've we've evolved this genetic way to it's like we were meant to eat these phytochemicals. We were meant to eat these plants, and they do amazing things when we eat them. They're changing our genes, the way our genes are activated, and they're doing enormously beneficial things by doing that. So like that's, to me, is so fascinating that, you know, we've evolved these mechanisms to basically not only handle the tiny little bit of stress from these phytochemicals, but we have a net positive effect by activating these robust antioxidant, anti-inflammatory pathways and these detoxification pathways. And so to me, that's like one of the coolest parts of it, right? It's not, people think about these phytochemicals, they all often think about it as antioxidant itself, like you're getting vitamin C or alpha tocopherol, one of the major forms of vitamin E. And it's just not the same at all. It's not the same at all, right, Jed?
Right, Rhonda. I mean, as always, you articulate these things so well, which is why you have such a large following. You hit the nail on the head. And yes, Mark Mattson, actually, Mark and I are both adjunct faculty at Hopkins now, which means only that you don't get paid. You don't get paid, and you can still sort of like use your library card there. But Mattson is huge in this field of hormesis, and he and I have talked, although not as much as I'd like to have over the years. And indeed, I mean, this is a wonderful way to look at them, and it's the way that for the 27 years that I was at Hopkins, it is the way we looked at a specific phytochemical called sulforaphane and its close relatives, and you know, it's exactly as you say. We have repurposed. We've enabled. Our bodies are enabled to detoxify many of them, not all, of course. There are plenty of phytochemicals that are highly toxic, and again, we could have 10 podcasts on them. But we have evolved ways to use them to gear up our own defensive mechanism. You mentioned the Nrf2 pathway. That's one that has interestingly sort of been uncovered or researched, put on the map, really, sort of in parallel to our work with sulforaphane and with many of the same people, the same research groups. And it's a huge detoxification pathway, but it's one of a number of mechanisms. I would put it sort of close to, I think I'd put it at the top of the list. But then talk to Mattson and Calabrese and people like that, and they will remind you very quickly, look, it's not just an individual phytochemical. And I used to say 25 years ago, yeah, we know that, but we're too dumb to know how to do the experiments to analyze the effects of multiple phytochemicals overlaying on each other, or, you know, combined. We're getting better at that. I'm not, but the field is getting better at that. And these synergistic effects are now being looked at, and it's amazing. And you don't, you know, ideally you want the plant in its matrix, perhaps with some other bioactive phytochemicals. Perhaps it's not other bioactive phytochemicals that are doing the trick, but it's just the way the whole schmear is delivered.
Can I tell you a story? I know this is like a tangent, but so I did my postdoc with Dr. Bruce Ames, as you know, Jed. Mm-hmm. And at the time when I joined his lab, they were doing research on something that they called the Cori bar at the time. And it was a bar that Mark Shiganaga, a good friend of mine who's just brilliant gut researcher, and Bruce and a few others, Joyce McCann, had come up with a way to get a broad range of micronutrients. So we're talking vitamin D, fat-soluble ones like vitamin D, omega-3 fatty acids. They had DHA in there. They had, you know, magnesium, B vitamins, you know, just like a panel of like the classical micronutrients that a majority of the US population is got insufficient levels of. But they also added some phytochemicals. They had some of these polyphenols from chocolate and some other phytochemicals in there. But with Mark's, you know, insight, he said, well, we need something that's like a food matrix. We need something that's like a food matrix that can mimic like what a plant would do if it had all these micronutrients and phytochemicals there. And so he came up with certain types of fiber. HPMC is one, and clinical studies done on this bar. Fast forward, they were trying to do a deconstruction trial to figure out, okay, what happens if you give people the Cori bar, this micronutrient bar with just the micronutrients, or just the phytochemicals, or without the fiber matrix, and what if they give them the fiber matrix without the phytochemicals and micronutrients? And what they found was that you needed the whole package. The benefits that were found with some of the biomarkers of lowering inflammation, increasing HDL, lowering some of the bad parts of LDL, small dense LDL, those didn't happen when you did just one or the other. You took away the micronutrients and the phytochemicals and everything needed the food matrix there. And that was just a great study because it really does drive home that concept of, this food matrix, this fiber matrix where you get all these micronutrients is important. It's important, very important. And so there's, like you said, there is synergy going on. There's additive effects. There's things that we don't understand. We don't know why, but it seems to be important to have the whole package.
And from the perspective of dietary recommendations, in a lot of ways, it doesn't matter what Rhonda or Jed know about how they work, if they work, right? I mean, if we don't have brilliant insights into why there are these synergies, the people that could benefit from them aren't going to care. All that's saying is, yeah. Anyway, I have to ask you, Rhonda, was this work you described before or after Bruce Ames' triage theory paper, which is a fascinating paper?
Yes, it was alongside the deconstruction trial happened after. So his triage, the Cori bar, which they called it at the time, it's now been remarketed. Another company bought it. It's called Heal Right, and I'm not affiliated with the company in any way, but so you can buy. These are now commercially available bars, but the Cori bar at the time it was called that. I mean, the research on that they had been doing for like at least 10 or 15 years, and so the triage theory came out. It was sort of side to side when they started embarking on this Cori bar research, and but they continued it on. And I joined the lab after he published the triage theory. I was a huge fan of that paper. We can talk about this some other time, but so Bruce has always been he's my mentor. He's one of my best friends. He's 93, going on 94 this December 16th. He'll be 94. Wow. And him and his wife Giovanna Ames, they're just like some of my favorite people in the entire world. So the Cori bar research continued on for just many, many, many years. Very, very interesting projects.
So I know we're running out of time. I just want to ask one more super important question. This is the one I've been waiting for all podcasts, but I want to know from each of you, what do you think the ideal human diet is? Like, what are the things that we really should be eating every day?
It's a tough one.
Who's going to start? I guess I can.
Help me, Rhonda.
That's a loaded question because I can just tell you right now, like if we're basing this off of empirical data, boy, do we not know. We just, so much of the nutrition field is based off of observational studies, and observational studies are very interesting and they generate really good hypotheses. And I think they're a really great start, but they're not the end all be all because you can't ever really establish causation due to the multiple potential confounding factors that could be playing a role in what the endpoint is that's measured. And so I think that it's really hard to know for sure, but I think we can look at some randomized controlled trials which use biomarkers as proxies. And I think just knowing what we know about the role of micronutrients. So these are the 40 or so essential amino acids, fatty acids, vitamins, and minerals that we need to get from our food to run our metabolism. Everything from, when people think of metabolism, they usually think about the way we metabolize food. But metabolism is so much more than that. Metabolism is going on in every organ in your body. It's allowing your neurochemicals and your neurotransmitter to fire so that we can engage in this conversation right now. It's allowing our heart to beat. It's allowing our liver to detoxify things. Metabolism is running everything in our body. And these, there's a variety of enzymes that are doing this. And those enzymes require cofactors. Cofactors are often minerals. They can also be vitamins as well, but they're ones that are needed from our diet. And there's been a variety of these nutritional surveys, the NHANES as they're called, that have identified micronutrient deficiencies in the United States. And also, of course, as Jed pointed out, globally, people living in other countries are undernourished in many micronutrients, and it's a really big problem. Here in the United States, we tend to eat enough food and get enough calories, and in many cases get too many of those calories, but we don't get our nutrients from the right food sources. So we're eating a lot of processed foods, packaged foods, foods that aren't whole foods that are vegetables, a lot of plants. And I would, I would argue that there's a big role for fish. It seems to be fishing also seems to be really important. And I think there's a lot of controversy when it comes to observational studies with meat and the role of meat in human health. And I think that if you start to unpack some of those confounding factors and look at the large studies that have looked at lifestyle factors, for example, there was a really large study, and I know Walter Longo, who's mostly vegetarian, was a co-author on this study. This was one of the largest studies that looked at plant-based diet versus people that are also eating meat. And, there's been so many studies showing that plant-based diets, people that eat plant-based diets have a lower all-cause mortality. They have a lower cancer-related mortality than compared to people that eat meat. But this was the first study that sort of looked at, okay, what about if we get rid of these unhealthy lifestyle factors like smoking, more than moderate drinking, obesity, sedentary? So those are the things. It's like, okay, well, what if people are not sedentary, so they're physically active and they're not obese and they don't smoke and they're not consuming excessive alcohol? Well, guess what? If they eat some meat, they have the same all-cause mortality as a vegetarian, or same cancer-related mortality as a vegetarian. And so at the end of the day, you have to go, well, maybe there's a lot more here to the story that we don't understand in terms of many different lifestyle factors, to kind of speak to what Sharon was saying earlier about all the factors that are contributing to Healthspan. Like if someone asked me, is the vegan the best diet? Well, I don't know, but like if you're obese and sedentary, you probably should be a vegetarian. I think that data suggests that. But it's not clear about people that are physically active and healthy in many other respects. Like, can they handle a little bit of meat? I think right now it hasn't been clear to me that they can't. But I also think that I have my eye on some other factors, like this new 5-GC, where it's this compound that is associated with inflammation, and it's sort of unclear. It's very concentrated in red meat. It's like, well, is that bad for us? I'm still trying to figure that out. Like, I don't know that we have all the data to definitively say yes or no. So, when you say what's the best diet, I don't know. For me, I try to eat something that's heavily plant-based with a lot of salmon and sardines and mackerel and the fish that are high in omega-3 fatty acids, but low in contaminants and mercury, for example. But I also do eat some poultry, and I do eat some red meat as well. And so I try to but I'm physically active, and I balance that with a lot of other healthy lifestyle factors. If there was some new research to come out that was pretty definitive that no, meat is not the optimal way to go, I would be the first to probably cut it out. But I think that the best answer I can give is a whole foods approach. I think that's something that's, and heavily phytochemicals, lots of colors, and as Jed pointed out, colors, and trying to get that diverse array of phytochemicals is important as well. So,
yep.
Jed.
Yeah, well, I agree with you. I agree with you, and I agree that there's a lot of personal choice involved. Not everybody, eating has to be pleasurable and fun, and not everybody likes the same things. And I think, you talked about lifestyle. I think Matthew Walker recently in his book has sort of pointed out that sleep is just a huge additional piece of the lifestyle equation that can't be left out, and may well be responsible for a lot of the problems that we're seeing in this country and other Western countries. But I mean, in terms of diet, I would channel, or the optimum, the ideal plate, Kevin. I would channel Marion Nestle and Michael Pollan. Hate to do it, but they, only because I'm jealous of them. They've so successfully talked about it, and stay away from the center of the grocery store is one of their big messages. And this is why I got interested in the company that Sharon, our co-host, started, called Foodnerd, because I looked at what she was doing when we first got in touch. I said, "Oh my gosh, this is actually what they're making is actually it's a fresh vegetable, but it's got some shelf stability. It's got huge shelf stability." And that's important because a lot of the reason people go to the center of the grocery store nowadays is because they, when they go to the periphery and they buy vegetables, especially things like sprouts, they get them, they throw them in the refrigerator. They don't use them that day. They come back, 3 days or a week later, and they say, "Oh my God, they're melted. They're mush. They're disgusting." Because a lot of fresh fruit and veg just don't keep that well, and there are all sorts of other problems with the way they're sold commercially. But so I and this is not a commercial message, and I am an advisor to Sharon's company, but I mean I'm extremely attracted by the idea that that one can deliver essentially unadulterated fruit and veg without, in a shelf-stable format. And yes, you take the water out, you dry them, but water's easy to add back in as you formulate and in your gut. The issue of meat. I mean, I told you I started out thinking I was going to be an oyster farmer. I also have seafood in my diet, and that's pretty much it. But my objection to animals and to meat, red or otherwise, is based on sustainability, planetary sustainability. And I'm not a member of PETA, but it's the cruelty to animals that I see in CAFOs, in the facilities that produce the animals for our consumption, whether that be poultry or beef or swine or whatever. So I avoid them. And I should interject that commercial aquaculture's got a huge share of problems coming up, and that we're fishing out our stocks of wild fish in the ocean. So there's a huge conundrum there, and I don't know how it's going to be solved, but a completely vegetarian diet would solve it if we can bring ourselves to understand a little bit better how that might look. And plenty of people do that all the time, right?
Bill Harris is talking about how research now is evolving on using genetically engineering microalgae to produce much more DHA and EPA, very similar to what you would get in a fish. And that's always been my concern with the microalgae is, geez, I don't want to take a whole bottle to get what I can get in like 4 fish oil pills, And so if people can get over their genetic engineering problem, I think in some cases, like if you're genetically engineering a crop to be resistant to pesticides and you dump like boatloads of pesticides on them, I'm like, well, that kind of sucks. But I mean, I don't want to consume that. But I'm like, I have no problem if you can genetically engineer microalgae to make robust levels of EPA and DHA, because we do need a sustainable way to get these omega-3 fatty acids to everyone in the world, in my opinion. So so that would be great if that happens sometime in our lifetime soon.
Yeah.
So is it thank you both for weighing in. Can I safely say that for both of you guys, the main thing is whole foods. Let's definitely the whole food matrix and trying to keep that intact as much as possible. Do you both agree that a large bulk percentage of your diet should be those whole foods?
I do. I'm not anti-supplement, but I think the supplements come in where people can't get or don't get certain requirements. So yes, the short answer is yes for me.
We'll have to do
Supplements are a
whole
great
podcast on supplements.
supplements are a great insurance. I mean, they're just
Yeah.
insurance for what you're not getting in your food. But yeah, I definitely think avoiding the processed foods is like one of the easiest things that you can cut out, and one of the lowest hanging fruits that will dramatically improve someone's health. And what does that mean? Cutting out then you have to eat something, and so you end up eating whole foods, right? So I mean, yeah, focusing on eating the whole foods means you can't eat that packaged stuff, and you're going to be just so much healthier by just doing that.
And that's something that really any income can really do. It just takes a little bit extra effort to make sure that you're avoiding all those very deliciously marketed packaged foods and really staying, with that. But it is really cost effective when you look at the, calories per spend. It's so much more less expensive for people. So
Totally.
But yes, thank you guys, both so much for your time. I feel like we could probably have like 30 different podcasts just on each thing. Literally just on the phytochemicals, and Rhonda, it was an absolute honor to have you on here. I don't want to steal any more of your time. But thank you both.
Thank you as well. It was really nice meeting you. And Jed's research definitely will outlive us all.
It's a delight getting to talk about it in less than highly technical terms, although we got a little technical. But yeah, thanks so much for having us, for having me. And I'd love to follow up on any of 10 million topics we touched on again. Thank you.
To everyone listening, thanks so much for joining us on this episode of #FoodTruth.
And if you share our mission for Food Truth, please be sure to rate, review, and subscribe, and visit antiages.org for more helpful tips and information.
And remember, don't forget to eat your broccoli.